All, it's a great privilege to introduce the resource person of today's program, Ms. Vasudharani, Mapple Trainer, Coimbatore. She completed MPhil at Government Arts College in 2017, Master degree at PSP College of Technology in 2013, PhD DHRL at Anna University in 2011, and BSc Applied Science at CIT, Coimbatore in 2008. She has teaching experience and also a trainer in lab Mapple. She conducted 3 courses under and organized 2 days workshop on employability skill and AICTE ISTE sponsored 1 week FDP on strategies and empowerment skill. She has delivered lectures on various topics like Fuzzy Logic Lab, MATLAB, numerical computing and software, and optimization technique, and also conducted hands-on training for MATLAB software. She is a life member in Indian Society of System for Science and Engineering and Technical Education. She has presented, published papers in international journals. To her credit, she has published a book, A Quick Tour of MATLAB. Now I request ma'am to take over the session.
The Mapple environment. So when you install it and then you open it, you will have this kind of thing, and you can see there are a lot of options, just like a MATLAB file, edit, view, insert, and all that. And you have a palette wherein which you don't need to search for any symbol, because I told you it is a symbolic workbook. Okay, we can write a equation as it is. How do we write in a notebook? We can write it. So all those things are available here. See, when you look at this, you can see favorites. Right now I didn't do anything recently, so you don't have the favorites. And the expressions, can you see a simple expression? You can save the variable and then you can use it. Just by clicking on this, you can get that equation here. So this is all already built in function. You just need to modify it and then you can utilize it wherever it is necessary. Okay, and you have got the calculus. So there is a function for finding the limit and differentiation and higher order differentiation, c d square and d power n. Until d power n we can differentiate, and integration also you have, and partial differentiation also, integral, double integral. You can do anything here. Okay, just like how do you do it in a notebook problem, you can work on here also. And there are some common symbols where you will be using in the equations also. So pi, e, I, j. This I, j and capital I will be used in the complex variables. Okay, complex variables. And I, j meant for vectors. And you know what are the uses of these symbols, right? And next one. So we have got some variables here. So whenever you create a variable, that will be stored here, just like MATLAB. Okay, whenever you create a variable in a MATLAB, you will be able to see that in a variable box. Okay, variable window, you'll be able to see. Okay, same kind of thing will happen here also. Okay, so why I'm doing the comparison is like you will find which one is easy better. Right, that is the reason. And you can inspect at every stage what is that variable value changes. So you can inspect also. Okay, you can view that, you can inspect it, or you can filter that variable and see what is happening, right? And here next comes a matrix. So you can directly create a matrices, and I will be shortly telling you.
Still shown. Slide is not. Have you changed the slide? No.
Ma'am, I'm not showing any slides, ma'am. I'm just sharing my Mapple window.
Yeah, the first the first page it is as it is. Have you not?
Yes, ma'am. No, I haven't changed yet because it's going to be a hands-on training. I think students are on the system, right?
They may not be having Mapple, but
okay, they can note down the commands. They can note down the commands, and whenever they get to work in Mapple, they can work on that also.
Yeah. They'll have to work it in college. Yeah.
Yes. Okay, I'm just introducing them the windows. Okay, so what are available in the Mapples? When they look into the Maple, open it, they will get this one. Okay, this is what I'm trying to do. Okay, and then here we have the workspace. Okay, the workspace. Here you can see that new document, new worksheet. Okay, so when you click on new document, you will get something like this. Okay, so where let me just tell you introduction. I can start typing my paper introduction, and then it's gonna be like non-executable math and start typing. You see introduction. Whenever I type something, it comes up, right? So like this, you can start working on it, right? So this is the first part. This is how we create, this is the command space, okay? This is where you execute the commands. So this is how we have to start. At the end, I'll show you how to do it. Now I'll start working, start introducing about a commands, and I'm not sure how much ever I can complete. I'll complete it in 2 hours, okay? So first let me start with the variables. Okay, so how to assign values to the variables. So here, unlike MATLAB, you will have a different commands. That's it. Okay, different notations and commands. That's it. But best of all, it's going to be very, very easy, right? So for example, if I have A, I need to assign any value to the A. See, there should be a colon equal to. This is an assignment operator. So if I say 2, it is going to be, can you see here, a variable value, and A, it has been assigned with 2, which I have executed right now. Okay, so sometimes you may feel that I don't want to see this one. So in that case, I'll show you how to suppress the output. So B is equal to 3, and when you use a colon here, it will suppress the output. But still, the variable has been created and the value has been assigned. This is the first thing I'm teaching you. This is an assignment variable, colon equal to, right? This is about the assignment. Next one, I'm just going to introduce you about the arithmetic operators, which is more important. Okay, so I'm just going to use this one as a calculator, normal calculator. I have values A and B. Let me just use all the operators and tell you. So it is going to be like A plus B. Okay. I'm getting the values here in the middle. Can you guys see? This is where when I click the enter button, I will get the answer right away here. And you can see it starts numbering. It started numbering, correct? So you can you don't need to worry about how do I number the equation when you start typing a document, research paper. You don't need to worry about it. See, that will take care. This is about addition, how to add two numbers. Next, subtraction is going to be A minus B. Click on enter. And division A slash B. When you press on the usual slash button, automatically it will take to the denominator, and then you will get the answer by clicking on the enter button. That's it. 2 by 3. And next, B for exponent. Okay. B caret symbol. Automatically the cursor move to the power. So minus 1. It is 1 by 3 because B value have assigned it as 3. So B power minus 1 is nothing but 1 by B. That is 1 by 3. That is about the exponent. And then mod. You have mod of A comma B. If I say, it's going to be 2. Can you guys see? Mod of A comma B. A I have assigned as a value 2 and B as 3. So when you divide 2 by 3, and you will get the remainder as 2, because 2 can't be divided by 3, and you will get a remainder. So mod is a function which will get you the remainder of the division. Okay, this is the answer here. You can see mod of a comma b. You can directly give mod of 3 comma 2 or mod of 1 comma 3, anything you can do that. Or if you want to assign this to another variable, yes, you can. Same way, like c colon equal to mod of 3 comma 4. We can do it like this. After finding the modulus, it has been assigned to the variable c, and here in the variable window, you can see that c has been updated here as a variable. Okay, so this is all about the arithmetic operators. So if you have any doubt, you can ask me. Otherwise, we can move on to the next one. Is it clear? Right. So next thing, before moving on to the next topic, I would like to tell you guys, there will be a lot of equation in your research paper. For example, if you have given all the equation and then you need to execute all at once. Okay, in that case, you can go to the edit button. Okay, and then do you see like executable math? Okay, execution, you can execute the selected portion. Like for example, only 2 lines of codes I need to execute, commands I need to execute. You can select that and then click on the edit, and you can see there is a, where is it, execute. Oh my god, execute selection part, only executing selection part. Once again, remove selection, select selection. Let me just try, you guys. So sorry, it's been a very long time since I used Maple. That is why I'm a little bit struggling. Okay. And I can select these 2 lines and then edit. I can click on undo output so that I don't see the output, and then I can select only a particular region and then select edit button. Okay. Sorry guys, I just forgot. If I remember, I'll just tell you. Okay. Sorry for that. Right. So next, this is about the arithmetic operators. And next one, there are few basic commands you need to learn. Okay. So what are the basic commands? Are like exponent. So you have to use a command exp of, for example, x square. Okay. This is going to be the answer for you. Exp, which is nothing but exponential function. Okay, exponential function. It gives you e power x square, or you can type like exponent of 3, which means that e power 3. Okay, this is how you get the exponent function. And there is another function. You would have learned that in the math, like modulus function or absolute function. Here we call absolute of minus 11. You will get the answer as 11, because modulus function, you know very well, modulus will convert all the negative numbers into positive numbers. How? We have got 2 different functions there. Minus x when the x is less than 0. X when x is greater than 0. Okay, so minus x, for example, if I take up minus 11, the minus x function will be selected. That will be used. So minus of minus 11 will get you plus 11. That is the reason we are getting for every negative values as a positive value. Okay, so you might have learned. If you have forgot, just try to recollect it. And next one is you can find the roots of any number. So you have to use this command root. of 8 comma 3. Root of 8 comma 3. I just need to click on, yes. Can you see? Root of 8 comma 3. That is nothing but 8 will be your base. Okay. And if I say 3, it is going to be cube root. Okay. If I say it is going to be 4, it is going to be fourth root. If it is 2, it is going to be second root. Square root. Root of 8 comma 2. If I say, you will get the answer as 2 root 2. Alright. This is how you find the root. And the next one, third of SURD, third of 8.0 comma 3. See, can you see? This is also a cube root of this for a floating number. Okay. These are the basic thing. And there is some operator. Apart from this arithmetic operator, there is a dot operator. So which is nothing but non-commutative application, multiplication. That will get you non-commutative. You know what is a commutative, right? A into B, B into A. So it will get you the non-commutative multiplication. Just like this. See, for example, 1 comma 2 comma 3. If I would like to multiply, dot, it's a non-commutative multiplication. Then 4 comma 5 comma 6. Okay, we'll get you non-commutative multiplication, that is 1 into 4 plus 2 into 5 plus 3 into 6, which is nothing but 32. All right. So this is all about the basic arithmetic operators. And then yeah, next we will move on to the trigonometric function. Okay. All right, so I've just restarted it. Restart will erase all the variables which you have used so far. Okay, this will restart it. So I'm just closing this one. Yeah. So next one, trigonometric function. Here, the trigonometric function, unlike MATLAB, the trigonometric function will take up only the radians as the value. Okay, only the radians as the value. Not like in MATLAB, like we can give both the radians value as well as a degree value to get the answer. That will not happen here, but only the radians will be accepted. Okay, so the function will be sine. Sine of radians will be in form of pi, in terms of pi. Okay, hope you know pi by 3, pi by 2, pi by 4 and all that, right? That is the radians form. Only that will be utilized here. So I'm just going to use the symbols here because I'm using pi. Pi by 3. So this will get you the answer of 3 by 2. Okay, it is a pi by 3 is nothing but 180 by 3. It is 60, right? So sine 60 degrees root 3 by 2. Same, you can try it for cos pi by 3. So these are the functions, sine, cos, tan. Let me try for tan pi by 4, okay? Tan pi by 4. And you have, same way, you have either 3 trigonometric function, that is cosecant, secant. So you can use secant. Secant of pi by 3. Secant of pi by 3. And cosecant, for cosecant, you'll have to use CSC, just like in MATLAB. So it is going to be pi by 4. Cosecant of 45 degree is root 2. Okay. And then cot of pi by 6. Let me try. So root 3. Okay, these are the trigonometric functions. This is how we are going to use it. Okay, in case I want to have like sine of x square, yes, it is possible. You can try it like sine, open the bracket, and then start typing your equation. So sine x. Okay, if you need to use it as a power, you need use a power, then you have to use a exponent symbol like shift caret symbol, shift plus 6, that will get you the exponent caret symbol, and then it's x square. So close the bracket, it's going to give you sine of x square. This is how you create a function, right? So sine, cos, tan, I think I've given you enough about the trigonometric function. And we have got sine h, sine, tan h and all that. It is an hyperbolic function. Hope you know what is a hyperbolic function. The sine, cos, tan functions are represented in the terms of exponent, e powers, exponent, e power x. Okay, so when it is represented in that format, we call that as an hyperbolic function. Okay, so now I can get you sine h of x. Okay, sorry, it's a sine h of x that will get you the hyperbolic function. Okay, once again. Sorry, my battery is dying. Okay, so this is about the sine, cos, hyperbolic functions. And next one, I would like to tell you guys about the conversion, how to convert. So there are functions for converting. Okay, so convert function. See, convert, C-O-N-V-E-R-T, convert. Open the braces, and you can use this convert function different ways. Okay, so just by giving the different parameters, that will get you the conversion. Right, let me start with one trigonometric function to log conversion. So you can use arc sign. You know that it is supposed to be for inverse. Okay, we use that arc sign, arc tan, to represent the inverse trigonometric function. Arc sign of x comma log will be represented using ln. Okay, here arc sign inverse trigonometric function is being represented in terms of logarithm. Same way you can utilize for every other trigonometric function or inverse trigonometric function. Okay, this is one conversion, and there is another way of using the convert, that is convert pi by 2 to degrees. Degree. Okay, once again, I forgot the S. Yeah, see, 90 degrees. So even when you get an error message, you can again go to the same place and then change whatever error has occurred, and then you'll get the answer. See, pi by 2 is equivalent to 90 degrees, right? So that has been given as the answer here, convert. And then you can convert here the complex numbers also. Using that, we have got a special function called polar function. Polar of t plus 4, and remember, capital I is used for complex, representing complex number. Okay, and then just give an enter. Polar of, can you see 5? You know that it is a r value, right? And then this is going to be tan inverse, that is theta. Hope you know that polar function, right? r into cos I theta plus sorry cos theta plus I sin theta. Right? For that we will be finding what is theta and r. Second, yes. So that is what been found using this polar function. Okay, r and tan inverse value, the theta value. Okay. So next, this is about polar function and the basic things. I would like to move on to the next one, like yes, combined function. Before that, let me give you guys about the factorization. Factorization, factor of will get you the factors of a quadratic equation, or even if it is a polynomial, you will get it. So for example, I'm just trying x square plus 2x plus 1, close the braces and enter, will give you x plus 1 the whole square, because the factors of x square plus 2x plus 1 is x plus 1 into x plus 1. So this is how you find the factors of a quadratic equation. And next one, it is going to be a very interesting thing, where in which you can utilize this function in different scenario. Okay, so let me just close this. I can save this work as Mapple workbook, that is .mw extension, so that you open this workbook again and then you can work it on the same functions again. Okay, you don't need to like I don't want to write down anything. You can save this as a workbook and you can utilize it anytime. Okay, is how you save it. I'm just not gonna save this document. Next, it's going to be combined function. Okay, COMBINE, combine. So what are we going to combine? We are going to combine trigonometric function. You can combine trigonometric function, you can combine conjugate of the function, and you can combine for example, like you have two exponent functions separately, and if you want to combine and add that powers when you have a same base, that can also be possible. I'll just give you all the type of combined function. Sine of x the whole square. Okay, comma trigonometric, right? So what happens here? One second. Why isn't working? Yes, you have got it right. So combining, which means that you have sine squared x formula. You know that cos 2x is equal to 2 sine 1 minus 2 sine square x. That formula has been replaced. Okay, the trigonometric identities, trigonometric multiple angle formulas, and sum and product formula, and what is it? Compound angles, everything you can substitute and you can get the values. I mean, get the formula by using the combined function. Okay, this is a sample of it, and I'm just going to show you another one. Combine sin x cos x. You know that sin x cos x, 2 sin x cos x is equal to sin 2x, right? Oh, sorry, here. Sin x star cos x, comma, trick. Oh, I should be getting. Okay, let me try in a different way. Let me try hyperbolic function. It didn't work for that. Okay. Sorry, it didn't work. Let me just figure it out what is it. Okay. And let me try next command. Combine of conjugate of x plus conjugate of y. Or let me try square, comma, conjugate. The conjugate of x is nothing but x bar, you know very well, right? And x square, conjugate of x square is going to be this, and this will be the answer for that, right? Next one, you can try this function also. Combine, sorry, I think I made a mistake here. That is the reason I'm not getting it. Yeah, sorry, this one, conjugate of x plus conjugate of x the whole square. This will be the answer. And next combined function will be e comma I combine. So by looking at the output, you will decide what it is. Because E is nothing but only one function. We don't have any other function. Okay, so that is the reason you are getting E itself as the answer. Now I'll show you again another function. Very equivalent to this I combine. Okay, so combine of 2 power A. Okay, and then 2 power B, comma, power. See, when the bases are same, it will get you the answer 2 power A plus B, right? So similarly, you can try a different function also. X power 2, Y power 3, and try with the power function. When only the bases are same, you will get this answer. Combining can happen, right? Because they are not like terms. So the answer you will get the same. Okay, this is a specialty of combined. These are the variety of combined trigonometry, combined trigonometry, combined conjugate, combined I combine, and combined power. Okay, these are all the variety of combined. And what else we have got? Other combined function. Combine of 3 ln of 2 minus 2 ln of 3. Come on, I'm just gonna combine based on the logarithm. Okay, see, based on the logarithm, it does the logarithmic concept, and then you will get the combination of it. Okay, this is the combined logarithm. And the next one, you can use this combined function for finding the composition of the functions also. You know the composition, right? Composition of a function, that can also be done here. Combine of f of f of t of x, comma. For that, you need to use the at symbol for the composition of a function. Okay, I think I have given the correct bracket. Let me just try it. f of f3 of x. I think I've given the correct answer, correct thing. I should be getting this. Once again, let me just check it. Let me try using this. Sorry guys, I'm not sure what happened here. I'll just give you the correct code, okay, later. It's supposed to be the correct code, but I don't know why it isn't working. Alright, I'll get you that. So you can do the composition also. Please do search it in the help. You will get it. Okay. So this is about the combine function. And I think I didn't miss anything here. Right. So let me just move on to the next type of function, that is expand. Okay. Just like combine, you have got expand function. Expand of x plus 1 into x plus 2. This is how you get the answer for expansion. Okay. Right, once again. Yeah. So x plus 1 into x plus 2. That gives you the expansion. I have made a dot symbol here. So that is a non-commutative multiplication. So expand will get you the multiplication of factors. And then what does this expand does? You can check it here. By x plus 2. Let's see what is going to do this. So you're getting the expansion, just a little expansion, you will get it. And then this is about the expansion. See, I'm just going to give you a gist of what are the important commands. Okay, so there are lots of commands available, like just like an ocean. When you just start exploring, you will get lot more commands. I'm just giving you few important things. Okay, very few important things I'm giving you because I can't cover everything in the stipulated time. So I'm just doing the giving you gist of it. So next, evaluation. So you can evaluate any factors. You can evaluate using evaluate A and open the bracket, and you need to use this A capital, this factor function. so that will evaluate any quadratic or polynomial function. X square minus 2y square. Let's see what they're gonna get. Root of, we are evaluating x square minus y square. So this is how we evaluate factors. The factors of the x square minus 2y square, we will evaluate it using this function, evaluation. And I think I've told you about factors. Next, I'm going to tell you about I factor. I factor. I factor of 6. Going to be 2 and 3. You know the factors, right? 2 times 3 gives you 6. That is the I factor numbers. And this factor, x cube minus y cube divided by x power 4 minus y power 4. So this is how the evaluation, can you see the simplification has happened, and then you are getting the factors. Okay, this is about another factor, and you have got variety of factor function. Factor of x power 3 plus 5. Comma complex. Let's try this. See the complex factorization. As you can see, there is a power 3 here, and it has solved it using a complex thing. So x power 3 means obviously you will get 3 roots. See here, this is the first root, second root, and the third root. Okay, if it is a square, you will get 2 answers. If you give a complex, you will get the complex answer. If not, you will get it as a normal factors. Okay, just like this. I'll show you. I think I've showed you in the previous one. X square plus 5x plus 6. And just give this one, you will get the factors of this. Okay, if you give complex, this answer is going to be in a complex form. That's it. And next, there is another factor function where that will allow you to get the factors by taking up a modulus with some number. Okay, I'm just going to try it with the 7, 2, and I'm just going to show you guys. Power 3 plus 3x and then see mod 7. So for the mod 7, we are going to get, sorry, here once again. See here, the factors you will get it with the mod 7. Okay, this is about a different, it shouldn't be like you don't need to fix up it. It should be only using mod 7. You can use any number. It is up to your choice. You can use mod 7, 2, 5, 3, anything. You can try it. Next, I'm going to show you for factor of x power 3 plus 1 comma alpha. The answers are going to be in alpha. Okay, if you need the answers in alpha, you can utilize that. Once again, I'm just searching for it. Or A. Let me just try it with A. mod 2. Factors extension invalid algebraic instruction alpha. So sorry. See, most of the commands I think I've used from 2018, and this version is 2021. I don't know what's wrong and it's not accepting it. Few commands, okay? You just try it with some other thing. So kindly bear with me because it's been very long time since I used Maple. Alright, so this is about the more factors, different types of variety of factor function. And let me just quickly move on to the next other functions. Simplify. We have got a simplify function. 4 power 1 by 2 and plus 3. Let's see what we are going to get. It's a 5. 4 power 2. Second square root of 4 is going to be 2 and 2 plus 3 is 5. So it is going to give you the simplification of any expression which you have given inside. Okay. So this is all about a few things, few introduction. And I will shortly teach you about differentiation, integration, and I'll teach you about plotting 2-dimension, 3-dimension, differential equation solving, that is ODE solving, and Laplace transform, and Fourier transform, and how to solve the differential equation using Laplace, and solve the series. I'll teach you all that. So these are all some basic things I would like to teach you guys. And then next one, we will move on to the arrays. Okay, this is about the basic commands. See, there are a lot of commands available, and I've taught you, like I've showed you only few things, only very few things. Okay, now I'm just moving on to the arrays. Right. So array has got variety of assigning or creating an array. So, but this is the basic one. 1, 2, 3. Okay. This is how an array of value we created. And what are the other functions? How do I create a matrix? That I'll teach you. And before that, I'll show you how to find the dimension of array. For that, you can use array dimension. So can you guys see that is 1.3? Okay, so this is nothing but it will tell you sometimes it used to represent the starting value and the ending value. Okay, this is a dimension. Dimension is 1 by 3. So here this dot is used to say that 1 by 3. Okay, so the array dimension. Okay, but somewhere if you use it for plotting and all that, it will tell you the starting value and the ending value. Just like 1, 2, 3, pi 2, pi minus pi 2 plus pi. So that there all we use these two dots to represent starting and ending value. Here it is representing the array dimension. Next one. So what are the other ways to create an array? I'll show you. B colon equals. This is more important. Array. The word keyword is very important. See here 2 dot t, which means that 2 to 3 dimension and minus 1 to 1 comma 1 comma 2 comma 3 4 comma 5 comma 6. Okay. Can you see? This is 2 by 3 or 2 minus 1 to plus minus 1 to 1. So this is how we create an array. This is another way of creating an array. Okay. So how to find the number of elements? That's also very easy. Array number of elements of B. This will get you number of elements. Okay. Next, there are a lot of functions which we can use it to create upper triangular matrix or lower triangular matrix or a square matrix, symmetric matrix, and all that we have got. And I'm just going to show you a few of that. So C colon equals array of triangular upper. And this is, I'm going to create an upper triangular matrix. Okay, I'm just going to give the order of the matrix, that is 1 comma 3 and 1 2 4. Okay, and then I'm just going to fill it with 1. See, 1 2 3, it represents the number of rows, and second one, it is nothing but number of columns. So 3 rows and 4 columns, and I'm filling it with 1 for upper triangular matrix. If suppose I use, instead of 1, if I use 5, it will be filled with 5 5 5. Okay, this is how we create an upper triangular matrix. And the same thing, if you try like lower, you will get a lower triangular matrix. We'll get this. Okay, this is about the basic array and how to fetch a particular value. So for example, I have got C here, right? So if I take up like C of 1 comma 3, I will get the particular value. Okay, so first row, 1 represents the first row and 3 represents the third column. So first row, third column value, I'll be getting it. See here, first row, third column, 1 2 3, it is supposed to be 0 and I'm getting the answer as 0. This is how we get the particular value. In case if I need to assign something, some value for that, see 1 comma 3 and just wanted to assign it, in that case, as usual, assignment operator, I can mark it as 10. Okay, sorry, it is an upper triangular matrix. I'm just trying to change it. Let me just try it with B. Okay, oh sorry, first row, second, array out of index. Huh? Sorry, array is supposed to be 3 rows. Okay, fine. All right, sorry, I'm not getting this. But this is supposed to be an assignment thing, and we can fetch the particular thing and you can assign also. But this is, I'm getting like array out of array index out of the range, and we'll start with second row and third column. I tried to do that, but I couldn't get it. But still, there is a 2 rows and 3 columns here. I couldn't make it. But it's okay, this is the command. Okay, just make a note of it, and then I can change the data type of the arrays. Okay, just like this. For example, I have this matrix or array 1 comma 1.2 comma 1 comma 4.78. In that, if I have such kind of thing, comma data type, whatever type I need to change, I can use it like this. The data type has been changed into float. So it was like decimal value. It has been changed into float with 8 decimals. Okay, 8 or more, the 10 decimal places, you will get the answer in case if you need anything. Okay, if suppose I need to have only 8 up to 8 decimals, I need it, I can make it like this. I'll get only, once again, okay, only up to 8 decimals I can get it. Okay, this is how you do it. And then next I'll move to the matrix. Matrix of 2 will get me the matrix of 2 by 2 order. I can make it like matrix of 3 by 3 or 4 by 4. It's an easy one to create a zero matrix. Okay, and the next one, matrix of 3 comma shape equal to identity. So you know that there is an identity matrix. So you will get that for third order identity matrix. And if you give 2, it is going to be 2 by 2 identity matrix. And see, matrix of 2 comma 3 will get you a zero filled matrix. Next, how do I get the values of insert the values of it? So you can try it like m1 equals matrix of 1 to 2, that is 2 rows, 3 columns, comma 5. See what I am getting? So 1 to 2, that means that 2 rows, 3 columns, you'll be filled up with 5. The number which I give here will be filled up with that. So next one. So how do I give the numbers which I wanted? So this is how you can give it. Matrix of, open this bracket, 1 comma 2 comma 3, close this and give comma for representing the second row, and 4 comma 5 comma 6, close the square bracket, and then this. Sorry, something wrong here. I should be getting this. Spelling mistake. Okay. Matrix, there was a spelling mistake previously. So matrix, and this is how you give your own. So now I'm going to do for double integration. First one with respect to y. First integration with respect to y, and second integration is going to be with respect to x. Okay, let me try it. So first function will be differentiated with respect to y. With that answer, we are going to differentiate with respect to x. This is what the answer I have got it. So it's so simple, right? Very, very simple. And I can do the partial differentiation also. Only thing is you need to define a function and then just click on here. You will get this. See, partial differentiation. Dou by dou x with respect to x, I'm just going to differentiate it because I've got x here in my function. So this, and then partial differentiation with respect to x square. I mean d by dx of dx by f of x. That is double differentiation, partial differentiation. This is the answer. And then you can even check for the Euler formula also. Okay, you can check for that also. Just by giving a simple, just I just created a function only once and I'm using all these here. Okay, I can differentiate this also. See here, very simple. D by dx of, this is second order differentiation I'm doing it. All the functions are available under the calculus tab. Okay, I've just made a second order differentiation. I can do the integration also, f dash of x using this. Okay, so you can do wonders here in the Mapple. This is about basic integration and differentiation. All right. So this is a differential equation. See here, this is a differential equation we have created with respect to x. All right, and then x, d square by dx square, and partial differentiation. So this is all about basic integration and differentiation. And you can use the this one also, like find the limit of, integration, definite integral. You can find the definite integral value also just by giving this. Okay, see here, I'm just going to integrate with respect to values. Like I'm just going to make a definite integral. So 1 to 2, I'm just going to integrate it. So our lower limit will be 1 and upper limit will be 2. And you can find the answer so very easily. With respect to x, I've integrated and found the definite integral of 1 to 2. Okay, this will be the answer. And you can try it for y also. Right, and you can try for both the values, like just like this. So first I'm doing with respect to y, and then with that answer I'm differentiating with respect to x. So very simple. See, you can do it. So I'm just trying it 2 to 3 for x, and for y let me just try 1 to 2. It can be any value. Hope you know the limits. The minus value should be below as a lower limit, and this is the answer. So easy, right? Only once I have created a function. So simple now. All right, so this is about the basic differentiation and integration. Now I'm just gonna tell you guys how to create a homogeneous equation. Okay, homogeneous differential equation. I'll show you. Restart. Okay. So for that also we need to use with algebraic curves. This is more important here, and just using the colon to stop the output. Okay, so it is algebraic curves. So now define the function y square minus x minus x cube. Okay, then homogeneous of f comma x comma y comma z. Okay, hope you know homogeneous function, where you will be added with another variable. 2 variable function will be converted into 3 variable function. So this is how you will, sorry, I think there is a spelling mistake. See, it was a 2 variable function, minus x cube plus y square. It has been converted to a 3 variable function, and there is a generating function which is available. You can check it in the help window. That function, based on that function only, we are getting this 3 variable equation. Okay, that 2 variable is converted into 3 variable. Okay, with that only it is happening, right? And then next, you can substitute some values. You can substitute the values in the homogeneous function or any function using this command: substitute of z equal to 1. So the previous one I have got z, so I'm just utilizing it here also. Into, because substitute z equal to 1, the bracket, this 2 represent, and which equation I need to substitute it. Okay, so you will get 2. Okay, this is how we get the substitution values, right? And then next one is about differentiation. Now I'll move on to the solving ODE, and then I will go to the plotting. Okay, that would be better if I do this order. So OD, I'm using the proper variable in order to differentiate the normal variable and ODE function. So y of x, okay, differentiate y of x, comma x, comma x. So with respect to x, I'm just gonna create a function x. Create a function y. See, the first x represent the y will be in terms of x, and the second one represents a differentiation. Okay, comma x, which is equal to 2 into y of x plus 1. Okay, this is ODE function. All right, now the function has been created. D square by dx square y of x, which is equal to 2y of x plus 1. This is the ODE function. Now, to solve this ODE function, we have D solve. D solve of ODE. That's it. This is how. I think you know how to solve the ODE function, right? So that will be solved here, and then this solving we can solve using the initial conditions. With the initial condition also we can solve it. For that we need to first fix what is the initial condition. What are the initial condition? So colon equal to y of 0. Okay, y of 0 is equal to 1, comma capital D represents the y dash. Okay, y equal y of 0 equal to 0, right? This is supposed to be an initial condition, right? So now I can use the same dissolve function and solve this ODE with the initial condition. See? So easy, right? Very, very easy. And then next one, this is about ODE's thing, and this you can solve using Laplace also. You can use the Laplace method to solve the ODE also, and I'll show you that. So solution, I'm just saving that in one variable. We solve of I see it. Sorry, ODE, comma with the initial condition, comma y of x, comma method. This will tell you what method, on which method we are going to solve. Laplace. Okay. See here, in the Laplace method, I've solved this ODE function. It is d square by dx square equal to 2y plus 1. All right. This is how you use the Laplace function. And next, you can solve using the initial condition. Okay. You can test for ODE. ODE testing also can be done. I'll show you that. ODE test, you have a function where you can solve it and test it also. This ODE, comma, with the initial condition, check, you make the ODE test. 0, 0, 0. This is the solution of the ODE. Okay, you can test also. This testing also can happen. You can do it. Next one, like series solution. Series, how to solve the series. Okay. Series underscore solution. D solve. FES, comma ODE, comma y of x. ODE function. This is a series method of solving it. And then for this also you can make an ODE test. Series underscore solution, comma ODE, comma ICS, comma the series. You can test this also. See 0, comma 0, comma 0. So for that ODE function, this series solution is a solution. This is how you test the ODE solutions. Okay. So just about ordinary differential equation. And what else we have got? Okay, let me just do this also. This also comes under ODE. Let me just tell it this. ODE. ODE equals. So it is going to be in terms of t, okay? Two variable equation equal to x of t. Sorry, I may be wrong in mathematical concept because it's been a quite long time since I learned in touch with maths. All right, so this is going to be another ODE function, and I think that I made some mistake here, missing a bracket. Yes, still. Okay. Sorry guys, 1 second. Differentiate with respect to t, yes. Differentiate y with respect to t and differentiate x with respect to t, which is equal to minus x of t. Yeah. It is correct. I don't know why it is showing wrong. I worked on it and then I'm not getting it. Okay. Sorry. I worked on it, but there is some error. I mismatched the, I think I misplaced the bracket actually, and I couldn't sort out where I have misplaced it, and I need to figure it out. I couldn't do it now because I need to finish up the plots also. Let me just quickly run through this. Okay. So let me just try with the Fourier and transformation first, okay? Let me just teach you guys about the transformation. So for that, we start. For that, you need to use with int trans. Okay. All right. So now you need to assume the lambda value. So 0 less than, where is the lambda? Let me check it in Greek symbols. Yeah, lambda, comma, 0 less than alpha. Okay, we need to have an assumption, and then after that only you can use the Laplace transformation. So f dot rand. So it is going to create random polynomial. Okay, it's going to be capital P, random polynomial of in terms of t plus a. Okay, and with respect to t, it is going to have it. We're going to create it, and how many terms? How many terms we need to have? So that also can be given. All right. So you will get a random polynomial. There is something missing. Okay. I don't think it will have it. It should be creating a random polynomial actually, but it's not creating it. So sorry, with int trans, it's going to be should be working. I don't know why it is making a problem. Okay, let me just give you the commands alone. You can try it like using Fourier of, and then f comma t comma p. Okay, Fourier transformation. This is the coding. I mean, this is the command for Fourier transform. Okay, so first the random polynomial will be generated. With that only you will get with that answer you will get the Fourier transformation for that function. Okay, same way you can try it for inverse Fourier. Inverse Fourier. This is the command. Inverse Fourier of. You can use capital P comma T. Okay, this is to find the inverse Fourier transformation, and then you can try Fourier cos, and invalid function argument. Okay, see, you will get the inverse Fourier transformation of the function, and then you can try for Fourier cos also. Fourier cos of f comma p comma t, and then Fourier sine, and then you can try these two. And for same way Laplace you need to replace the word Fourier with the Laplace word. That's it. So Apart from that, the same thing. First, you need to create a function, and then Laplace transformation. You can use Laplace of f comma t comma p. That's it. So it's for Laplace transformation. All right. So now it's already time. Let me just quickly go through with the plotting. It'll be so interesting for you guys. I'm quickly moving on to the plotting. So I'm just going to give you a simple plot, two-dimensional plot first. Okay. Plot of sine of x. I'm just going to draw plot for sine x from the values minus pi to plus pi. Okay. Minus pi to plus pi. So I just need to use two dots and then pi. Okay. And for y also, I can have y equal to minus 1 to plus 1. And I hope you know all the sine cos values varies between minus 1 to plus 1. See, this is how. So when you start typing the thing, you will get this, give this function. I mean, you give this command and you will get a image here. Okay. You can just change it also. It is going to be very interactive, and you can move it and you can expand it. You can check it. Okay. You can save this also. See, you can change the style. You can say it as a polygon outline, line, a line function, and color also you can change it. I can change the color, transparency, how much ever, whatever thing you need to change it in this graph, you can do it. Okay, this is about the simple two-dimensional plot. And what are the other possibilities you have? Other two-dimensional thing is plot of sine of t, okay, comma t cube, comma t equals 7 to 22. We can give the values like this also. See here, it changed the axis and the values. You can change it. So two different graphs combined together, you can plot it. Okay, this is about two dimension. And the most interesting thing, I'll show you the next one. Plot of just sine, comma, minus pi to plus pi. Just simple this one, okay? Sorry, sir. Just if you have an inbuilt function sine, cos, tan, just give the principal value alone. All right. So this gives you the two-dimensional graph. And the most interesting part comes next. I can plot it a specific for a specific value also. Just like this, 5 comma 5, and then 6 comma 6, 7 comma 7, 8 comma 8, and then close this. See here, the specific value also we can draw, right? And then it's the interesting part now, plots, and then use animation. Okay, you can animate and check. So for that, you need to use the animate in the next to the plot. Okay, plots, animate, and then give the function there, the usual code. You have it, right? Plot of, I'm just going to give you a different function, two variable function, sine of x, a into sine of x, comma x equal to 0 to 10, comma a equal to 0 to 2. Okay, and you will amazed to see this. Why is it not working? Once again, let me just check. Into x10, 0 to 2. Why isn't working? Oh, sorry. It's a capital P. Oh my god. Okay. If we use only one function, that's why. Animate spelling is also right. Plot of sorry, it isn't working. Plot animate. I don't know why. What happened? 3 dimensions isn't working. Let me just try for 3 dimension. If it is working good, then I'll tell you what is wrong. 3 dimension of oh, thank God. So this is how we get the 3 dimension graphs. Okay. XY value. If you wish to give the XY value, you can do it. You can rotate it any way you can rotate and see. Okay, you can change the colors also by right clicking on it, and then you can change the color and you can do it in any way. You can convert this into 2 dimension also. Okay, just by this, change the color and then the dots, you can change anything. Okay, right, this is about 3 dimension and few more 3 dimension functions we have. Let me just quickly show you guys. Plot 3D of xy. You can give the values also specifically equal to 0 to 1. You can give the specific value and then also you can draw. This is the 3 dimension for xy graph, and then you can have like this plot. 2 different values also can be given, 2 different axes. So that is sine of x plus y, comma x equal to minus 1 to 1 and y is equal to minus 1 to 1. Okay, you can rotate it and check. All right. So anyway, let me just try once more the animation. Plot of animate plot 3D sine of A star plus y square dot this function with x is equal to minus 2 to 2 comma y equal to minus 2 to 2 bracket comma capital A is equal to 0 to 2 star pi. Okay, let me try this. Oh my god, it isn't working. Okay, once again, let me just try it. Once again, guys, and let me just do this once again. Okay. Give me a second. Okay, fine, it's working. Sorry, I forgot to play. See, after doing the animation, you need to right click. You need to right click on it, and then you will get the animation option, and then you will have play button. Okay, this is how you will get the animation. Okay, right? So let me just try one more thing. One more 3-dimension. Let me just try this. Okay. Right click on it, animation, play. So this is how the animation happens.